Welcome back to Scale of the Cosmos. Smash like and subscribe. Today we're diving into the dark side of the universe. Space is beautiful, but it's also one of the most lethal environments imaginable. We're talking about 10 things out there that would absolutely obliterate you in seconds, sometimes in ways so wild they sound made up. So buckle up, grab a snack, and let's explore all the ways the cosmos wants you dead. Point 1. The vacuum of space. Let's start with the most obvious one, but trust me, it's way more terrifying than you think. The vacuum of space itself is a death sentence, and the way it kills you is genuinely horrifying. If you stepped outside a spacecraft without a suit, you'd have about 15 seconds before you lost consciousness. That doesn't sound too bad, right? Wrong. In those 15 seconds, your body would go through some absolutely nightmarish changes. Here's what would actually happen. First, the air in your lungs would rush out almost instantly. You'd want to hold your breath, but that would be the worst possible move. The pressure difference would actually rupture your lungs from the inside. Astronauts are specifically trained to exhale immediately if they get exposed to vacuum, because keeping that air inside would tear apart your respiratory system. Next, the moisture on your tongue, eyes, and other exposed wet surfaces would start to boil, not because of heat, but because of the lack of pressure. Water boils at lower temperatures when there's less pressure, and in the vacuum of space, there's no pressure at all. Your saliva would literally bubble away. Your tears would evaporate. Then there's the swelling. Without the pressure of an atmosphere pushing in on you, your body would start to expand. The gases dissolved in your blood, and tissues would come out of solution, just like opening a soda bottle. You'd swell up to about twice your normal size. You wouldn't explode like in the movies, but you definitely look like a balloon animal made of meat. After about 15 seconds, the lack of oxygen would make you pass out. After 90 seconds to 2 minutes, you'd be dead. And here's the worst part. If someone actually rescued you within that first minute and got you to a pressurized environment, you might survive. There have been a few accidents in space training where people were briefly exposed to vacuum and lived to tell about it. They described it as feeling their saliva boil on their tongue, which honestly sounds like the worst possible thing to experience right before passing out. So yeah, the vacuum of space isn't just empty nothing. It's an active killer that turns your body into a swollen, oxygen-deprived science experiment. And it's everywhere out there, just one suit malfunction away from disaster. Sleep tight. Point 2. Solar radiation. You know how your mum always told you to wear sunscreen? Multiply that by about 1 billion when you're in space. The sun pumps out massive amounts of radiation, and Earth's atmosphere and magnetic field shield us from most of it. But out in space, you're getting the full unfiltered blast. Here on Earth, we're protected by our magnetosphere, an invisible bubble of magnetic energy that deflects charged particles from the sun. We also have an ozone layer that absorbs ultraviolet radiation. Without these protections, life on Earth wouldn't exist. The sun would have sterilized our planet billions of years ago. But the moment you leave Earth's protective bubble, you're getting hit with cosmic radiation, ultraviolet rays, X-rays, and gamma rays. Astronauts on the International Space Station get a small dose because the ISS is still partially within Earth's magnetic field. Even so, they receive about 80 to 160 millisieverts of radiation per year, which is hundreds of times more than what you'd get on Earth. Now imagine going beyond the magnetic field, like to the Moon or Mars. The radiation dose skyrockets. And if a major solar flare or coronal mass ejection happened to hit you while you were unprotected, you'd absorb a lethal dose in minutes. We're talking acute radiation syndrome, where your cells start dying off rapidly. Within hours, you'd start vomiting and feeling extreme weakness. Your bone marrow would start failing, meaning your body couldn't produce new blood cells. Your immune system would collapse. Your skin would start peeling off. Internal bleeding would begin, In severe cases, your nervous system would shut down within days, and you'd die a horrifying slow death from radiation poisoning. Even smaller doses over time can cause cancer, cataracts, and DNA damage. This is one of the biggest challenges for sending humans to Mars. The trip would take about 6 to 9 months each way, and astronauts would be exposed to dangerous radiation the entire time. NASA is actively researching shielding technology, but right now, going to Mars is essentially signing up for a higher cancer risk. Here's the kicker though. Galactic cosmic rays, which come from outside our solar system, are even more dangerous than solar radiation. These are particles accelerated to nearly the speed of light by supernovas and other cosmic events. A single high-energy cosmic ray can pass through your body and damage cells along its entire path. Astronauts have actually reported seeing flashes of light when these particles pass through their eyes, leaving little tracks of destruction in their retinas. So basically, you can see your own death happening in real time. The universe really has a flair for the dramatic. Point 3. Micrometeoroids. You'd think the biggest threat in space would be massive asteroids, right? Wrong. The real silent killers are tiny particles called micrometeoroids, and they would absolutely destroy you in space. These are essentially space dust, particles ranging from the size of a grain of sand down to microscopic specks. Doesn't sound dangerous, does it? Well, here's the thing. These particles are traveling at speeds of up to 160,000 miles per hour. At those velocities, even a tiny grain becomes a high-velocity bullet capable of punching through metal, glass, and definitely your body. The International Space Station gets hit by micrometeoroids constantly. NASA has multiple shielding layers specifically designed to absorb these impacts. Even with protection, the ISS has dings and dents all over its exterior. Spacewalking astronauts have to be extremely careful because a micrometeoroid hitting their suit could puncture it, leading to rapid decompression and the vacuum death we already talked about. Now imagine you're floating in space without a suit, or with a damaged suit. A single micrometeoroid the size of a grain of rice would hit you with the force of a bullet. It could pass straight through your body, leaving a clean entry and exit wound. Your blood would start boiling out of the holes. Your suit, if you had one, would depressurize. You'd be dead within seconds. What makes this scarier is that you can't see them coming. Micrometeoroids are too small and too fast to detect with the naked eye. They're basically invisible cosmic snipers. One moment, you're admiring the view of Earth. The next, you've got a hole through your chest the size of a pencil eraser, and you're bleeding out into the vacuum. Speaking of larger meteoroids, those are even worse, just less common. A meteoroid the size of a baseball, traveling at 40,000 miles per hour, would carry the energy of a small nuclear bomb. If one of those hit a spacecraft or a person, there wouldn't even be remains to recover. You'd just be vaporized into a cloud of subatomic particles drifting through the cosmos forever. Even worse, there's growing concern about space debris. Decades of human activity have left thousands of pieces of junk orbiting Earth. Old satellite parts, paint flecks, lost tools from astronauts. These objects are also moving at thousands of miles per hour. Astronauts on the ISS have had close calls with debris, sometimes having to maneuver the entire station to avoid collisions. We've literally turned our own backyard into a deadly minefield. The cosmic ocean is full of bullets, and most of them are invisible. Point 4. Spaghettification by a black hole. Okay, this one has the absolute best name in physics. Spaghettification. Yes, that's the actual scientific term. And it's exactly as horrible as it sounds. If you fell into a black hole, you'd be stretched into a long noodle of human goo before being crushed out of existence. Here's how it works. Black holes have insane gravitational pull, like beyond comprehension levels of gravity. The closer you get to a black hole, the stronger that pull becomes. But here's the catch. The gravity at your feet would be significantly stronger than the gravity at your head. even though your body is only about 6 feet long. In a normal gravitational field like Earth's, the difference between the gravity at your feet and your head is so tiny you don't even notice it. But near a black hole, that difference becomes enormous. Your feet would be pulled toward the black hole way faster than your head. The result? You'd be stretched out like a piece of taffy, getting longer and thinner until you become a strand of atoms. For smaller black holes, this would happen well before you cross the event horizon, the point of no return. You'd be dead long before reaching it. For larger supermassive black holes, the tidal forces are actually weaker near the event horizon because the gravity gradient is more gradual. You could theoretically cross the event horizon of a supermassive black hole alive, but you'd still be crushed eventually as you spiral toward the singularity. Inside the black hole, things get even weirder. Time and space behave so strangely that physicists aren't even sure what really happens. Some theories suggest that as you approach the singularity, you'd experience time running infinitely slow from one perspective and infinitely fast from another. Your body would be crushed into a single point of infinite density. Or maybe you'd come out the other side as a white hole. Or maybe you'd enter another universe. We genuinely don't know. What we do know is that you absolutely cannot survive falling into a black hole. The intense radiation around active black holes alone would fry you long before spaghettification took over. Black holes are surrounded by accretion disks, swirling clouds of superheated matter falling in. The friction in these disks creates temperatures of millions of degrees. So even if the gravity didn't kill you, the radiation would. The really wild thing is that, to an outside observer, you'd never actually appear to cross the event horizon. Time slows down so much near a black hole that someone watching you fall in would see you frozen at the edge, getting redder and dimmer, eventually fading into invisibility over billions of years. From your perspective, though, you'd cross it in moments and meet your doom. So if you ever find yourself heading toward a black hole, my advice is to enjoy the view real quick, because the universe is about to turn you into a cosmic noodle. There's no escape, no rescue, just stretching, crushing, and possibly entering another dimension. Honestly, that's probably the coolest way to die in physics. Point 5. The surface of Venus might look like Earth's sister from a distance, but trust me, you do not want to visit. Venus is what happens when a planet goes completely off the rails. The surface of Venus is hands down the most hostile environment in our entire solar system, and it would kill you in about 3 different ways simultaneously. Let's start with the temperature. The surface of Venus reaches about 900 degrees Fahrenheit. That's hot enough to melt lead. It's hotter than the surface of Mercury, even though Mercury is closer to the Sun. Why? Because Venus has a runaway greenhouse effect from its incredibly thick atmosphere, which is mostly carbon dioxide. The heat gets trapped and never escapes. If you somehow stepped onto Venus, your body would be cooked instantly. Not slowly roasted, instantly cooked. Your skin would melt off, your blood would boil from the heat alone. You'd basically turn into a human-shaped puddle of charcoal in seconds. And that's just from the temperature. But Venus isn't done with you yet. The atmospheric pressure on Venus is about 92 times greater than Earth's. That's equivalent to being about 3,000 feet underwater. The crushing pressure would simultaneously squash you flat, so you'd be cooked and crushed at the same time. 2 horrible deaths happening simultaneously to the same body. Oh, and we're not even close to done. Venus also rains sulfuric acid. Yes, actual sulfuric acid falls from the clouds. The good news is that the acid evaporates before reaching the surface because it's so hot. The bad news is that the upper atmosphere is filled with corrosive acid clouds that would dissolve your suit, your spacecraft, and pretty much anything else you sent up there. The Soviet Union actually managed to land probes on Venus back in the 1970s and 80s. These were called the Venera missions. The longest any of them survived was about 127 minutes before being destroyed by the heat, pressure, and acid. They sent back the only photos we have of Venus's surface, and the images are eerie and yellow with a hellish landscape. Then the cameras melted, and here's the cherry on top. Venus has weird super-rotating winds in its upper atmosphere that move at hurricane speeds, about 200 miles per hour. So as you're being cooked, crushed, and dissolved, you'd also be getting blown around by acidic superstorms. Venus is basically a planet-sized murder weapon. It's the universe's way of warning us not to mess with our climate too much, because if we do, we end up like Venus. So Venus is technically in the habitable zone of our solar system, but calling it habitable is the cosmic understatement of the century. It's a literal hellscape. Mars looks like a tropical resort by comparison. Point 6. Jupiter's radiation belts. Jupiter is a beautiful planet to look at from a distance. Those swirling cloud bands, the iconic Great Red Spot, the dozens of moons. But get too close to Jupiter and you'll discover something terrifying. Jupiter has the most intense radiation belts in the entire solar system, and they would absolutely destroy any unprotected human in seconds. Earth has radiation belts too, called the Van Allen belts, but they're nothing compared to Jupiter's. Jupiter's magnetic field is about 20,000 times stronger than Earth's. This massive magnetic field traps charged particles from the Sun and accelerates them to insane speeds, creating belts of high-energy radiation around the planet. If you flew a spacecraft near Jupiter without proper shielding, you'd absorb a lethal dose of radiation in minutes. We're talking thousands of rems of radiation, when even a few hundred rems can be fatal. NASA's Juno spacecraft, which has been orbiting Jupiter since 2016, has special radiation shielding made of titanium to protect its electronics. Without that shield, all of Juno's circuits would have fried within hours. For a human, exposure to Jupiter's radiation belts would be almost instantly lethal. Your cells would be destroyed faster than your body could possibly repair them. You'd experience acute radiation poisoning so severe that you'd die before symptoms even fully developed. We're talking complete cellular breakdown, hemorrhaging, organ failure, the works. All within a matter of minutes to hours. This is also why exploring Jupiter's moons is so challenging. Some of the most interesting moons, like Europa and Io, orbit within these radiation belts. Any astronaut visiting Europa would need incredible shielding, way more than what we currently have for Mars missions. Europa is one of the top candidates for finding alien life because of its subsurface ocean, but actually visiting it is going to require some serious engineering breakthroughs. Io has it especially bad. This little moon is the most volcanically active object in the solar system, with hundreds of active volcanoes spewing sulfur miles into space. And it's right in the middle of Jupiter's radiation belts. So Io is simultaneously being cooked by volcanic heat from below and irradiated by Jupiter from above. It's the worst real estate in the solar system. The radiation around Jupiter is so intense that it can actually damage the planet's own moons. Scientists have observed how Jupiter's radiation chemically alters the surfaces of Europa and Ganymede, breaking down water ice and other compounds over time. The radiation literally weathers the moons. So Jupiter is gorgeous, sure, but it's also a planet-sized particle accelerator, surrounded by death rays. It's the kind of planet that looks friendly until you get too close, and then it cooks you with invisible energy from 1,000,000 miles away. Beautiful, but deadly. Just like that one ex everyone has. Point 7. A direct hit from a solar flare. The sun seems pretty consistent from where we're standing. It rises, it sets, it gives us a tan. But the sun is actually a violent, unpredictable thermonuclear monster, and it occasionally hurls massive bursts of energy and matter into space called solar flares and coronal mass ejections. If one of these hit you directly, while you were unprotected in space, you'd be obliterated instantly. Solar flares are sudden eruptions of intense radiation from the sun's surface. They release energy equivalent to billions of nuclear bombs detonating simultaneously. The radiation travels at the speed of light, So by the time you saw a flare happen, you'd already be getting hit by it. There's no time to react, no warning, no escape. Now, if you were on Earth, the atmosphere and magnetic field would protect you from most of the harmful radiation. Solar flares can disrupt radio communications, mess with satellites, and create beautiful auroras at the poles, but they're not lethal at ground level. We're shielded. But if you were in space, especially outside Earth's magnetosphere, a major solar flare would be a death sentence. The intense X-rays and gamma rays would blast through your body, destroying cells, scrambling DNA, and causing acute radiation syndrome at lethal levels. You'd absorb a fatal dose of radiation in literally seconds. Coronal mass ejections, or CMEs, are even more dramatic. These are massive bubbles of plasma and magnetic field ejected from the sun's corona. Imagine billions of tons of superheated charged particles screaming through space at millions of miles per hour. When a CME hits Earth, we get spectacular auroras and sometimes power grid disruptions. When a CME hits an unprotected astronaut, they'd basically be hit by a wave of radioactive plasma at incredible speeds. The most powerful solar storm ever recorded was the Carrington event of 1859. It was so intense that telegraph systems around the world failed, and some operators got electric shocks from their equipment. Auroras were visible as far south as the Caribbean. If a Carrington-level event hit Earth today, it could fry our entire electrical infrastructure, causing trillions of dollars in damage and potentially killing millions through cascading failures. Now, imagine being in space when something like that happened. You wouldn't just lose power, you'd be literally inside the storm. The radiation would be off the charts. There's actually a famous near miss from 1972, when a massive solar storm happened between two Apollo missions. If astronauts had been on the lunar surface during that storm, they likely would have died or suffered severe radiation sickness. We got incredibly lucky. NASA actively monitors the sun for signs of upcoming flares and CMEs. Astronauts on the ISS have a small storm shelter inside the station they can hide in if a major event is detected. But for future missions to the Moon and Mars, solar weather is a major concern. We're going to need much better shielding and prediction systems if we want to send humans long distances safely. So the next time you complain about the sun being too bright, just remember it's basically a massive thermonuclear bomb 93 million miles away that occasionally throws temper tantrums. And if it ever caught you out in the open without protection, you'd be cooked from the inside out before you even realized what happened. Point 8. Falling into the sun. Speaking of the sun, let's talk about what would happen if you just decided to take a swim in our local star. Spoiler alert, you would not last long. Falling into the sun is one of those classic sci-fi death scenarios, but the actual physics of it is way more brutal than most movies show. Here's the wild thing. You'd start dying long before you actually reach the sun. The closer you got, the worse things would become. Even being millions of miles away, the radiation alone would start cooking you. The Parker Solar Probe, which is currently the closest human-made object to the sun, has special heat shields designed to withstand temperatures of about 2,500 degrees Fahrenheit. And that's at a relatively safe distance. Let's say you were in some kind of indestructible spacecraft and you just kept going. Here's what would happen as you approach the sun. At about 4 million miles out, you'd enter the sun's corona, the outer atmosphere. The corona is weirdly hotter than the surface, reaching temperatures of over 1.8 million degrees Fahrenheit. Your body would instantly vaporize into atomic particles. You'd cease to exist as a recognizable being. But let's pretend you're somehow still surviving in your magic spacecraft. As you got closer to the surface, called the photosphere, you'd encounter temperatures of about 10,000 degrees Fahrenheit. The sun's surface is constantly churning with massive convection cells the size of Texas, each one rising and falling as superheated plasma circulates. There are also sunspots, which are slightly cooler regions caused by intense magnetic activity. but they're still way hotter than anything on Earth. If you somehow made it past the surface, you'd start descending through the sun's interior, where things get even crazier. The radiative zone, just below the surface, has temperatures of millions of degrees. Photons of light produced in the core take hundreds of thousands of years to bounce their way out through this dense soup of particles. Eventually, you'd reach the core, where temperatures hit about 27 million degrees Fahrenheit. The pressure here is so extreme that hydrogen atoms are being smashed together to form helium through nuclear fusion. This is what powers the sun. You'd basically be inside a continuous thermonuclear explosion that's been going for 4.6 billion years. But here's the thing. You'd never actually reach the core. The sun is so massive and so dense that long before you got there, you'd be torn apart at the atomic level. Your atoms would be ripped apart, and your subatomic particles would join the swirling plasma soup. You'd essentially become part of the sun, forever. The really wild part is that the sun is so massive it's mostly empty space at the atomic level, but the energy and pressure are so extreme that nothing solid can exist. You wouldn't burn up like a marshmallow over a campfire. You'd be deconstructed into pure plasma. It would take about 2 months for an object falling from Earth's distance to actually fall into the sun, by the way. Our planet is moving sideways at 67,000 miles per hour, which is what keeps us in orbit. If you somehow stopped that sideways motion, you'd start falling toward the sun, but it would take a while because of the distance involved. So falling into the sun is the ultimate death by fire. There's no body left, no remains, no anything. You just become part of the energy that's been keeping our solar system alive for billions of years. Pretty poetic if you don't think about how excruciating it would be. Point 9. Neutron star gravity. We've talked about black holes. But let's talk about black holes' weird cousins, neutron stars. These are some of the most extreme objects in the universe, and they would kill you in ways that are arguably even more horrifying than a black hole. At least with a black hole, you get to enter another dimension or whatever. With a neutron star, you just get destroyed in the most brutal way physically possible. A neutron star is what's left over when a massive star runs out of fuel and collapses. The outer layers explode outward in a supernova, while the core gets crushed under its own gravity. The result is an object that takes the mass of our entire sun and crams it into a sphere about 12 miles across. Yes, you heard that right. The mass of a star in something the size of a city. This makes neutron stars some of the densest objects in the universe. A teaspoon of neutron star material would weigh about 1 billion tons on Earth. That's the weight of every car in America combined, in something the size of a sugar cube. The density is just incomprehensible. Now here's where things get terrifying. Because of this insane density, the gravity at the surface of a neutron star is about 200 billion times stronger than Earth's gravity. If you somehow stood on a neutron star, you'd weigh about 14 billion tons. Your body would be crushed flat instantly, like a pancake hit by a galactic-sized hammer, but you wouldn't even make it to the surface alive. As you fell toward a neutron star, the tidal forces would tear you apart long before you arrived. Just like with a black hole, the gravity at your feet would be way stronger than the gravity at your head. You'd be stretched out and ripped apart at a molecular level. The technical term, again, is spaghettification. But honestly, with neutron stars, it's even more violent than with a black hole. Then there's the radiation. Neutron stars often have insanely powerful magnetic fields, sometimes 1 trillion times stronger than Earth's. If a neutron star spins, it can become a pulsar, beaming out concentrated radiation along its magnetic poles. These beams sweep through space like a cosmic lighthouse. If one hit you, you'd be irradiated to oblivion in microseconds. Even more extreme are magnetars, a special type of neutron star with the strongest magnetic fields known in the universe. A magnetar's magnetic field is so powerful that if you got within 1,000 miles of one, the magnetic field alone would kill you. Magnetic fields don't usually hurt people, right? Well, magnetar fields are so strong they can actually distort the atoms in your body. Your atoms would be stretched into long, narrow shapes, completely disrupting your cellular chemistry. Every chemical reaction in your body would fail. You'd die instantly at the molecular level. Magnetars also occasionally release massive bursts of energy called starquakes, where the surface of the magnetar shifts and releases radiation that can outshine entire galaxies. These bursts have been detected from thousands of light years away. If a magnetar starquake happened nearby, it could literally sterilize entire star systems. Here's the truly mind-bending part. The closest known neutron star to Earth is about 400 light years away. That's relatively close in cosmic terms. We are, in some sense, living next door to objects that could obliterate us if we got even slightly too close. The universe is basically a quiet neighborhood with a serial killer living a few houses down. We just don't bother them, and they don't bother us. Most of the time. Point 10. The cold of deep space, saving one of the wildest deaths for last. Let's talk about the cold of deep space. Most people don't realize just how cold space actually gets. We're talking about temperatures so low that they would freeze you solid in ways that would mess with your understanding of physics. The temperature of empty space, far away from any stars, is about minus 454 degrees Fahrenheit. That's just barely above absolute zero, the theoretical lowest possible temperature in the universe. Absolute zero is the point where atoms basically stop moving entirely. Empty space is just a few degrees above that. Now here's something counterintuitive. If you were exposed to space without a suit, you wouldn't actually freeze instantly. Heat transfer in space is way different from heat transfer on Earth. On Earth, when you're cold, heat is being conducted away from your body by air or water molecules. But in space, there's almost nothing around you to absorb your heat. So you'd actually lose heat slowly through radiation, not conduction. That said, the heat loss through radiation is still significant, especially when you're surrounded by the deep cold of space. Over time, you would absolutely freeze. Your body would slowly cool, your tissues would begin to crystallize, and you'd become a frozen corpse drifting through space. This process would take hours, maybe even days, depending on conditions. So you'd be dead from other causes long before freezing becomes your main problem. But let's talk about the coldest known place in the universe. It's called the Boomerang Nebula, and it's about 5,000 light years away. The temperature there is about minus 458 degrees Fahrenheit, which is actually colder than the natural cosmic background temperature. How is that even possible? The Boomerang Nebula is actively cooling itself through a strange process. A dying star at the center is shooting out gas at incredibly high speeds, about 350,000 miles per hour. As this gas expands rapidly, it cools down even further, similar to how a can of compressed air gets cold when you spray it. The result is the coldest natural place we've ever found in the universe. If you were somehow exposed in the Boomerang Nebula, your body would freeze faster than anywhere else known to exist. The cold there is so extreme that even the molecules in your body would slow to almost a complete stop. Chemical reactions, including all the ones that keep you alive, would grind to a halt. You'd basically become a perfectly preserved popsicle, frozen for eternity. Cold also has weird effects beyond just freezing. At extreme low temperatures, materials behave in strange ways. Metals can become brittle and shatter like glass. Lubricants freeze solid. Electronics fail. Spacecraft visiting cold environments need special heating systems just to keep their internal components functioning. If you tried to operate a normal vehicle or piece of equipment in deep space, it would simply stop working. Even more wild, at temperatures very close to absolute zero, quantum effects start to dominate. Some materials become superconductors, allowing electricity to flow with no resistance. Helium becomes a superfluid that can flow uphill against gravity. The laws of physics start to look fundamentally different. So in a way, the coldest parts of the universe are where physics gets weirdest. For astronauts, the cold of space is just one of many threats they need to manage. Spacecraft and spacesuits have heating systems to keep humans alive in the cold, but they also need cooling systems for when they're in direct sunlight, because the temperature swings in space are extreme. The sunny side of the ISS can reach 250 degrees Fahrenheit, while the shaded side drops to minus 250 degrees Fahrenheit. That's a 500-degree temperature swing on the same object at the same time. So yeah, space is cold. Not gentle Arctic cold. Not even Antarctica cold. We're talking about temperatures so extreme, they slow down the very atoms that make up reality. The universe is mostly an empty frozen void, and if you ever forget your jacket, you're going to be in real trouble. So there you have it. 10 ways the universe is just waiting for the chance to obliterate you. From cooking you on Venus, to stretching you into spaghetti near a black hole, to freezing you solid in the cold dark voids between stars, space is one of the most hostile environments imaginable. And yet somehow, we still want to go out there and explore it. Humans are wild like that. The next time you look up at the night sky, just remember that every one of those tiny twinkling points of light is a place that would absolutely murder you if you got too close. The universe is beautiful, but it is not safe. It's a cosmic horror movie playing out in slow motion across billions of years, and we're tiny little observers watching from our protected blue marble. If you enjoyed this video, smash that like button, subscribe to Scale of the Cosmos for more cosmic content, and drop a comment letting me know which death sounded the most horrifying to you. Personally, I'm going with spaghettification because the name alone is amazing. Also, let me know what topics you want me to cover next. The biggest things in the universe? The most beautiful places in space? Theories about how the universe will end? I'm down for anything. Until next time, keep looking up, stay safe down here, and remember, the universe is way scarier than you ever imagined. See you in the next one.